Let's take a look at the 10.8 warm-up problem. The radius of each circle is 3. Triangle WXY is equilateral. A, find WY. Okay, so here is WY. It is one side of an equilateral triangle. If this triangle is equilateral, there's a few things we know. One thing is all three sides are congruent. The other thing we know is each vertex angle, so angle X, angle Y, angle W, they are all 60 degrees. So if we're going to find WY, I don't have to find WY, I could find any of these sides. So I'm going to focus on XY just because it's a little easier for me to work with it being horizontal right here. So the first thing I know is this is a radius of 3. And these two circles are tangent at that point. And so these two radii combine to make a distance of 6. And the same thing happens over here from C to R, 3 and 3. So from Q to R, 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So from Q to R, we have a distance of 12. Now the tricky part here is the distance from X on to where the circle is tangent to side X, Y. Remember what we said angle X is? What is the measure of angle X? 60 degrees. So if I connect X to Q, we've gone over this a few times. We end up with a kite, 90 degrees here where the radius meets the tangent line. Also, if you did it on the other side here where the cursor is, you would also have a 90-degree angle. And we have a tangent angle here at X. So this segment from vertex X to the point of tangency, and this segment here from vertex X to the point of tangency, those two are going to be congruent as well. So we end up with a kite. And if I draw in segment XQ, that's going to divide that kite in half. So we end up with two triangles that are congruent to each other. And those two triangles happen to be right triangles. So remember, vertex X we said is a 60-degree angle. I should say angle X is a 60-degree angle. And so we bisect that and we get 30 degrees. 90 degrees here. So we have a 30, 60, 90 right triangle. Think about what this segment length is from Q to that point of tangency. Well, that's a radius, right? So it's got a distance or a length of 3. All right, so I've got 3 drawn in there. In the 30, 60, 90 triangle, 3 is what side? The short leg, the long leg, or the hypotenuse? It's the short leg. And what do I want to find? The long leg or the hypotenuse? We want to find this side right here, and that is opposite our 60-degree angle. So we want to find that long leg. So what is this length? It is going to be 3 root 3. And the same thing is going to be happening over here as well. This is also going to be 3 root 3. So as we find the length of xy, which is the same as wy, we add all this together, and we get w equals 12 plus 6 root 3. On to B, find the ratio of the perimeters of triangle ABC, triangle PQR, and triangle WXY. Okay, let's go ahead and find WXY. We know it's going to be 3 times each side for our perimeter. So 3 times 12 plus 6 root 3 gives us 36 plus 18 root 3. We can't multiply just one of these two terms by 3. We have to multiply them both by 3. We're multiplying the entire side length by 3. Let's talk about triangle ABC. ABC, okay, ABC is right here. Let me erase some things and draw in triangle ABC. All right, so here I've drawn in triangle ABC. Center A, center C. The distance from two centers of two tangent circles is going to be twice the radius, right? So from A to that point of tangency is going to be a radius of 3. From that point of tangency on to C, that's going to be the radius of 3 as well. So AC has a length of 6. And BC, same thing, 3 here, 3 here. That's a length of 6 as well. And AB also has a length of 6. So 6 plus 6 plus 6, the perimeter of ABC is going to be 18. Let's do the same thing for PQR. So I've drawn in triangle PQR. And remember earlier when we found the length from Q to R, it was 3 plus 3, which is 6, plus 3, which is 9, plus 3, which is 12. So each side of this triangle is going to be 12. You can check me on that if you want to, but that is 6. This is 6. That'd be from R to B is 6, from B to P is 6, from P to A is going to be 6, and from A to Q is going to be 6 as well. So we have 12 for each side. All right, so let me write that in there. So the perimeter of triangle PQR is 12 plus 12 plus 12, or 36. So now we need to find the ratio of the perimeters. Triangle ABC, triangle PQR, and triangle WXY. So I'll do. We weren't directed what specific ratios we had to find. So let's do ABC to PQR, and then we'll do PQR to WXY, and then we'll do ABC to WXY as well. So the perimeter of triangle ABC to triangle PQR, 18 to 36, which is 1 to 2. Let's do the same thing for PQR to WXY. All right, now be careful with this one. So triangle PQR, that is 36, to triangle WXY, that is 36 plus 18 root 3. Now remember, since we're adding in the denominator here, when we're dividing, we have to divide by the same number with both of these terms. With multiplication, that's not the case, but with addition, sometimes I still see geometry students mess this up. So we can't divide this first term by 36 and the second term by 18. It's not allowed. Each of these have to be divided by the same number. So we can divide them both by 18, right? And we can divide the numerator by 18 as well. So 36 divided by 18 is 2. 18 divided by 18 is 1, so we get 1 root 3. And 36 divided by 18 is 2. So we get 2 to 2 plus root 3. That is that ratio. And now let's do the same thing for triangle ABC to triangle WXY. So the perimeter of triangle ABC is 18. To the perimeter of triangle WXY, this is 36 plus 18 root 3. Again, we are adding in the denominator, so if we divide by some number, each of these terms has to divide by that number. We can't pick and choose one and not the other. So we can divide 36, 18, and 18 all by 18. 18 divided by 18 is 1. 36 divided by 18 is 2. 18 divided by 18 is 1. So we get 1 root 3, or just root 3. So 1 to 2 plus root 3 is our ratio there. All right, thank you very much. And just a quick word before I go, this is another way to represent those ratios there, 1 to 2 to 2 plus root 3. So if you wanted to go that route, that would be an acceptable way to report this answer.